Before we begin with the crosses, a few friendly reminders on genetic problems. Remember to assign letters to represent the alleles. For complete dominance problems, use the same letter. The capital letter should always represent the dominant allele. The lowercase letter should represent the recessive allele. Keep in mind, we want to use letters that look different when they are capital and lowercase. For example, capital T, lowercase t. We would not want to use S because when we are rushing, we may not be able to tell the difference between the two letters. Read the problem thoroughly to determine the parent genotypes, as well as there will often be clues throughout the problem. If, for example, they give you the clue that an individual is heterozygous, the capital letter should always be written first. Remember, we are using Punnett squares to solve the problems to predict the genotypes of the offspring. While solving these problems, please keep in mind, you must always have a key for the letters, show the genotypes of the parents, show your work in a Punnett square, answer what the question is asking, and finally circle the answers to the questions. Monohybrid crosses involve a single gene where one allele is dominant over another. In other words, the dominant allele masks or hides the recessive allele. You will use an uppercase letter for your dominant allele and a lowercase letter for your recessive. If you look at our picture below, we have a homozygous recessive individual, a homozygous dominant allele pairing shown, and a heterozygous pairing shown. In this example, dog's wire hair A is dominant to smooth little a, and a cross of a homozygous wire-haired dog with a smooth-haired dog. What will be the genotype and phenotype of the F1 generation? Remember, the first step is to make sure we make a key. Capital A is wire, little a is smooth. The problem tells us we have a homozygous wire-haired, which would be capital A, crossed with a smooth-haired dog. Now, because the smooth hair is the recessive allele, we know this individual must be homozygous recessive to indicate this trait. Third, we make our Punnett square. Remember, choose a direction to fill in your alleles of one parent, and then fill in the alleles of the other parent. This will help you to avoid mistakes. Next, reread the question. What will be the genotype and phenotype of the F1 generation? Our genotypes are 4 out of 4, capital A, lowercase a, or heterozygous. And our phenotypes are all wire-haired. Remember to circle your answer. Another example. Wood rats are medium-sized rodents with lots of interesting behaviors. You may know of them as pack rats. Let's assume that the trait of bringing home shiny objects, capital B, is dominant to the trait of carrying home only dull objects, lowercase b. Suppose two heterozygous individuals are crossed. How many of each genotype would be expected if only 4 offspring were produced? Again, we'll make our key. Big B would indicate a pack rat bringing home shiny objects. Little b is a pack rat bringing home dull objects. 2 heterozygous individuals. This means we will have both a dominant and recessive allele in each parent. Again, I am filling in one parent and then filling in the other parent. Out of these 4 children, the question asks how many of each genotype would be expected. We would see 1 out of 4 homozygous dominant, big B, big B. 2 out of 4 heterozygous, big B, little b. And again, keep in mind, we want to write our capital letters first. And 1 out of 4 little b, little b. Circle your final answer. In mice, black fur is dominant over white fur. If 2 mice are crossed and produce all black offspring, list the possible genotypes and phenotypes the parents could have. Again, we begin with making our key. Capital B is black. Lowercase b is white. If 2 mice are crossed and produce all black offspring, list the possible genotypes. We can look at our Punnett squares and we can do a variety. We can do capital B, which is homozygous dominant, crossed with another homozygous dominant parent. And when we do this Punnett square, we would expect that all children would have black fur. This is one of the parent genotype possibilities. Also, we could cross a homozygous dominant parent with a heterozygous parent. And again, all of the offspring have black fur. That is a second possibility. A third possibility of the genotypes of the parents is homozygous dominant with a homozygous recessive. And again, all of the children have black fur. Keep in mind, we know that the children must have at least one capital B allele to have black fur. The other allele could also be dominant or recessive. Therefore, any Punnett square combination that would result in the children having at least one dominant allele would be a possible genotype for the parents. In humans, earlobes are either free or attached. The free earlobe is completely dominant over the attached earlobe. So we'll represent capital F for free. Lowercase f will be attached. A man with free earlobes. Now, when they say free, we know that man must have at least one capital allele, dominant allele, to be free, marries a woman with attached earlobes. Because she's exhibiting the recessive trait, she must be homozygous recessive. Of their 4 children, 1 has free earlobes and 3 have attached earlobes. Give the genotype for the man, his wife, and their children. We've already discussed that mom must be homozygous recessive to have attached ears. We've also discussed that the man, or dad, must have at least 1 capital F allele. Now, many of you may have already jumped to the conclusion that if they have 3 children who have attached earlobes, that dad must also have a lowercase f in order for that to happen. Which means if we cross a heterozygous individual, such as the father is, with a homozygous individual for the recessive trait, such as mom, we see a Punnett square with a 50-50 chance of either free earlobes or attached earlobes. What this means is that the children who have free earlobes are heterozygous for the trait, and the children who have attached earlobes are homozygous recessive. Now, some of you may be surprised because there are more than 50% of the children having attached earlobes. What you need to remember with probability is that every time there is a child born, the odds are 50-50. It's much like flipping a quarter. You can get 50-50 heads, 50-50 tails out of 100. If you flip the quarter roughly 100 or 1,000 times, you'll see that 50%. If you flip that quarter only 10 times, you might see heads come up 8 times and tails come up 2 times. In this case, with 4 children, the attached earlobes came up 3 times and the free earlobes came up once. Again, remember, each child has a 50-50 chance. The next example. In humans, having a widow's peak is recessive to a normal hairline. I'm going to use H for my key. Capital H will represent normal. Lowercase h will represent a widow's peak. Cross a woman who has a straight hairline whose mother had a widow's peak. Remember, if the mother had a widow's peak, mom must have been homozygous recessive, little h, little h. And if mom passes an allele on to her daughter, that daughter must receive a lowercase h because mom only has 2 lowercase h or recessive alleles in order to have a widow's peak. Now in the problem, the woman has a straight hairline, which means she also has the dominant allele for a normal hairline. And again, she gets the recessive allele from mom who had a widow's peak. We are crossing her with a man who is homozygous recessive for the widow's peak. What are the genotypes and phenotypes of their offspring? The genotypes are 2 out of 4, or 1/2, or 50%, will be heterozygous, big H, little h. And then the other half, or 2 out of 4, or 50%, are homozygous recessive. Phenotypes are 2 out of 4, have a normal or straight hairline, and 2 out of 4, or again, 1/2 or 50%, have a widow's peak. and we circle our final answer.